Okay, today is kind of an extension day about polynomials, and I need to explain this more fully. You can write a polynomial as two things being multiplied plus their remainder. Let me talk about that in a context that I think you'll understand better. If I take 23 and say, does 5 go into it? Well, yeah, it goes into it, but there's a remainder. Everybody do that one. Do long division on this, and it'll just give you a good reminder of what normal long division goes like. Show all the little steps in there too. And then when you're done, would you please write it as like 5 times 8 plus 3 or whatever it is? Because two things can be multiplied, and then you'll have a remainder left over. This is not the right answer, of course, but it'll be in that format. Two things being multiplied. All right, so here's a quick reminder. You should have gone, 5 doesn't go into 2. You could put a 0 here, but you don't have to. Then 5 goes into 20 how many times? 5 times 4 is 20. Subtract that. This is a 3. That's called a remainder. And I told you yesterday that you could say that that was 3/5. And that's true because 5 times 4 and 3/5 is equal to 23. That works. But that's not the format that we want it in. What we want it in is 5 times the 4 doesn't actually work. We got to kind of like help it out a little bit by adding the remainder. Raise your hand if you had 5 times 4 plus 3. Okay, good. Now use the same concept to do this one. X plus 1 goes into x squared plus 2x plus 1. Except that would factor too nicely. I'm going to make it not work. Because that way there'll be a remainder. I did that on purpose. This is not going to work out nice. There is a remainder. But you can do the same thing as we just did up here and write your answer as this times this plus the remainder. So let's see. You should have said x goes here, and then x times x makes x squared. X times 1 makes 1x. And nothing was wrong at first because opposite, opposite. These are supposed to cancel, and it did. And this doesn't have to cancel. 2x minus an x makes just x. Bring that down, plus 4. The problem is you can't put anything here that's going to totally fix it. But I'm going to use plus 1. 1 times x is x. 1 times 1 is 1, and they don't match up nice. Opposite, opposite. 4 minus 1 is 3 is the remainder. So you should have said it was x plus 1 and x plus 1 plus 3. There's your hand if you had that one right. Okay. You get if that 3 was really a 0, if this had worked out and the remainder was 0, you wouldn't need to write plus 0. You'd just write that. You just write the two factors. Putting plus 0 after is kind of silly. Okay. Now let's do one with synthetic, just to see if you remember synthetic. This one has a root. And the root is going to go in this little box like this. Okay. And the root, not the factor, the root is -3. My question is, use that to factor this polynomial using synthetic. I'll pause for a second while you try that. Okay, so the -3 is the root or the 0, and I'm going to now do synthetic to see what, drop it like it's hot, it factors to. -3, add them, multiply them, add them, multiply them. Did you get a 0 at the end? That's a good sign. Okay, so that means this thing factored. And the factors are, by the way, you can't leave it like this. This is just a bunch of gobbledygook. The actual answer is x plus 3, and this one is this is the constant right here. This is how many x's you have, and this is how many x squared you have. So it's x squared plus 6. That's factored all the way. How many of you got that one right? Good. Now, one more extension to this. If this thing is really a 0, I want you to prove to yourself that it actually makes that equation equal 0. Stick in -3 and prove to yourself that this thing actually equals 0. In case you have trouble with that, -3 cubed is -3 times -3 times -3 is -27 plus, and then just keep going from there. It's a 0, so that's what it does. It makes this thing equal 0. -27, and that's 9 times 3 is +27, and those cancel. And this becomes -18, and then +18, and those cancel, so it equals 0. Cool. So why would you ever need to know that? Because what if they gave you the same exact setup, and they changed that 6 to a 5p? They could say, well, since you know that -3 is a 0, what does p have to be? Well, then if this thing has to equal 0, I say equals 0, and then I stick in -3 where? And for the x's, and then do it. Solve. Solve for p. Once you stick that in, it's easy. AG, what do you think? Did you get -27 and then +27 and then 5p times -3 and then +18 equals 0? Same thing as me? Okay. So then these cancel off. Let's get them out of there. And then what? -15p plus 18. And then what? And then what? And you get positive. Ooh, you're reducing. Awesome. I'm going to rewrite this as 6 times 3 and 5 times 3. Final answer? You are so right. Now let's actually go put 6/5 back in here. If I put a 6/5 in here, get the 6's or the 5's would cancel, and there would be a 6x just like it was before. Okay. So that's how you could use that. Now here's another way to say it that's similar but different. -1, oh no, here's how they'd say it. X plus 1 is a factor. I'm going to change this to a Q. -1 is a factor, or sorry, X plus 1 is a factor, which by the way means what's a root? So what's a 0? Isn't a root and a 0 the same thing? So what's a 0 for this thing? -1. So solve it. Find Q. Okay, since I'm just trying to show you that they don't always come out and say that -1 will make this thing equal 0, because that would be too easy. They might say that's a factor, and you have to go, okay, well, if that's a factor, then -1 is a root or a 0. So that means this whole thing will equal 0 when I stick in -1. And here. And I get 2 times -1 makes -2. And this would make 1 squared is, or -1 squared is +1 times 2 is 2. And this one makes 5, and then plus Q equals 0. And I can look at this and go, well, that's going to equal 0, so that has to equal -5. Raise your hand if you had -5. Oh, -5? What? I'm confused. Oh, okay, sorry. That's a -1 there, which makes this a -5. I was a little too sloppy. And if that's a -5, what's Q got to be? +5. To make this all equal 0, Q, you can just solve it like normal and put those together, and that makes -7 plus 2, which makes -5. Add 5 to both sides, and you'll have Q equals 5. Cool. Okay. So now the last topic for today is, let's say I told you that this polynomial that I'm about to write has a 0 of 7, that's weird, a root of -9, zeros and roots are the same thing, and it is going up on the right. Write the polynomial that would have all of those things going for it. There is multiple answers. Yours just better have those 3 things, those 3 characteristics. Let's pause for a second. Let me try that. All right, so I hope that you saw this as a equation that would have to go up on the right. If it's going to go up on the right, then it has to be positive in front. What if I had made it to go down on the right? What would you have done to change this? Just throw in a negative. Right there, it'd be fine. Could it have also gone in here? Sure, that would have worked. That would have made it go down. All right. So, and you've got your roots right. Nice job. Okay. Now, what if I'd have said that the 7 has a multiplicity of 2? Who would have known what to do? Yes, sir? Yep, that would have given it a multiplicity of 2. What if I said that at -9, the graph appears to snake through? Then what power am I implying? 3. 3, 5, or 7, or 9. Very good. Doesn't have to be 3. Okay, I think you get the idea, and that's what your homework is like for tonight. So, covered everything we had to cover, and let's get to your homework. Everybody find the first page of it. Looks like that. It's got a little bit of a rainbow going on in the upper right. Find that page. Okay, number 41. It tells you that there are 4 zeros, +2, -2, +1, and -1. So don't overcomplicate it. It's not a plus and minus. It's just 4 different things. So you got 4 different parentheses. 1 for the +2, 1 for the -2, etc. You can just write in a polynomial. And then how in the heck is this supposed to have 117? Oh, I could just throw in 117 x to the 4th at the front of the thing. True or false? Wouldn't I also need x's in all of those? And wouldn't that make it the leading term of this polynomial actually x to the 8th then? Okay, so that wouldn't work. Where should I put the 117? I could put it in the front, or I could put it in front of any of these x's. I wouldn't want to put it in front of more than one of them, or you'd have to do 117 times 117. I could put it there, or I could have put it here, or here, or here. In front of any of those x's would have been fine. All right. And then there we go. That's the idea. All right. Now, a couple of these are going to make you think, which is good. This is one of those problems where they told you a 0 in a funny way. What did they effectively say? Hey, this is a 0. What did they say is a 0 here? 3. I said 3 is a 0. I know the equation doesn't equal 0 right now, but you can say, I know it will, because if it's really a 0, then this whole equation will equal 0. And then you can solve it. And this one adds a little bit of a challenge. We are skipping the last one, number 11. But this one adds a little challenge, and I'll just give you this hint. There's 2 variables you have to solve for, and you can't do 2 variables unless you have 2 separate equations. This will tell you one of your zeros, and this will tell you the other 0. So you got 2 separate zeros. You can have 2 separate equations. When I've got 2 separate equations, I can solve and find both A and B. All right. That's your only hard problem for today. It might take you a while to figure out what to do there. But this is not that hard. Okay. That's all I got for you for today.